Hello, everyone. Welcome back. Artisan of Glimmith, pure logic playthrough. We've done 79 puzzles so far. No idea how many there are, but I'm sure there's a lot. So we're going to keep going. I appreciate everyone who's been following along with this series. I appreciate the feedback. And where is it starting us? Way back here. All right. So we've got the Glimmith Bridge complete. Glimmith Overlook complete. The Rose Windows complete. 33 out of 33. And then there's a +2. That's nice. And then over here, we've got quite a bit left over on this side. The Gemini and Delta. 21 out of 21. We've got, we're already silver. It looks like we have 9 more to complete the, I think this is the puzzle we were looking at here. All right, this is a difficulty 5, which means it probably will take us a little longer than most, but we'll get through it. We got 3 shapes to work from. We got a 1x2, we got a corner piece, and we got the L piece. We've got the deltas and the Geminis. Delta just means it has to be different across the borders, and Gemini means it has to be the same. Now, I think we can start right here. Starting in the middle. I don't know if this is a 2 or a long one, but either way, this has to be part of a shape. And the same thing's true here. Now, it's possible that one of these connects. Otherwise, it's going to be having to go down that way. This is very, very interesting. These 2 shapes. Because this tells me that these 2 are different, but this tells me that these 2 are the same, which means this region and this region cannot be the same region. So if this one is a new region, if it would have to come out. So two options here, right? We've already said that the corner piece does not go in here. There's no place for the corner piece. So this means that one of these is the L and one of these is the 1x2. And either one can be the L and either one can be the 1x2. But what it can't be is this. That is not viable, because then this cannot meet the requirement. So this could be the L going this way, and then this is the 1x2. Okay. Or this could be the L, and this is the 1x2, and that would make this the 1x2. So both of those are viable. There's 2 options here. But my eyes are drawn now. We have a second. Gemini and Delta, because these 2 are the same and these 2 are different. So if this was the L, then there would have to be an L here. And then this would have to be the 2. That works. So I could put like an L in here, and I could put a 2 here. Like that. That meets all the criteria. If this, boy, these colors are, give me some more colors. All right, if this were the L, then this would have to be a 2 of some kind, like this. And this would have to be the L up here, like that. I do see a problem. This. If this were an L, across the line, this would also have to be an L. How can that be? How can that be? You can't fit in there. This can't be the case. So this is the 2. Sorry, let's get rid of that one. This has to be the L, which means there's an L here. Don't do that because it could be like this. But we do know that these three are part of it. That's what we can say. This will be a 2. This tells us this has to be the same, so we can't have a corner here, right? Because that fails. So if this has to be a 2, then this has to be a 2, this has to be a 1 by 2. I think that's pretty forced. Let's go down to this corner right here. This could be a 2 or it could be an L. If it's a 2, then this could be the L. Yeah. If this was an L, then this would be like a 2. I don't think we can resolve that. Let's go up to this one here. This has to be part of an L. Don't know if it goes this way or that way, but those three are definitely together. Which means this on this side is not an L. So it's either a corner or it's a 1 by 2. Now this is very interesting right here. How do I fill out these 3 spaces? I need an L. If I do this, that everything here's happy, but now I'm stuck with this 1 space. And I can't fill it because this is also an L. And if I do it the other direction, it's the exact same problem. This one's happy, but I have a 1 space. And I think what that's telling us is neither of these can go into that corner. They both have to go around, which means this will be a corner piece like that. These are different, so this is not an L, so that's done. Those start something. It could be an L, it could be a 2. That has to just be a 2. There's nothing else that can go there. This is not the same as a 2, so it's a corner that goes around. We'll start with this. Can this be an L? I'd have to put an L in here. So if I made this an L, then this would have to be an L, and this is no man's land. So I don't think this can be an L. This is a... So I think this is a 2. This is a 2. All right, this is the same. This is different. So this has to be a 1 by 2. If it goes this direction, this is in no man's land. So it has to go this direction, which means that has to connect to make that so it can expand. All right. I don't know if this is an L or not. This is the same as this, so that is forced. And I can't put a corner in here. This is going to have to just be an L. All right, this comes up. Does it make an L? It does not, because it has to be different than this. So that is that. So this is a 2 as well. And is this an L? Nope, because it would have to be. So that's like that. Then we do this. And now the question is this an L? It could be an L. I think it has to be an L. Can't be a corner. That's it. That's it. All right. Any more hidden over here? Come look around. Okay, we got some more up here at the front somehow that I did not take advantage of. All right, our shape bank. We got a 1 by 3. We got a corner. We have both deltas and Gemini in place. And where do we start? I think we start right here. This has to come out. It either comes down or it comes over. If it goes across, then this would have to be a corner. I don't see a problem with that per se. This is not a 1x3. I can see that because then you couldn't put it here. Actually, let's just look here. What is the shape that goes here? And the answer is, I know it's not a 1x3. It's going to be a corner. Now, I don't know if it's this direction or this direction, but it's part of a corner. Which means this is not, or no, this also has to be a corner. Because it's the same, it's a Gemini. So it could be something like this. Could be something like that. Like this. Like that. Lots of options, but it's a corner piece. These are corners. I don't know how to mark that. So if that was a corner like that, yeah. But these are both corners. Now, if this were a corner, that would force this to be like that. All right, everyone. I accidentally muted my microphone at this point in time. So I recorded the video, but I did not record my thinking. And obviously that's a big part of what it is. So right now I'm going to come back over. I'm just going to try to voice over the logic here as I was doing it. Obviously you're not hearing me doing it in real time. You're seeing me solving it in real time, but my thought process obviously not being captured. So right now I'm looking at the board and I'm looking at this top right side. I'm comparing the deltas and seeing, you know, if it's a 1x3 versus a corner piece, how these all interact here. And I'm not making much progress. And so I come to the conclusion that I'm probably looking in the wrong spot. And at this point I say, you know what? When all else fails, probably need to look elsewhere. So we're looking here at the bottom, looking at, we have to get a 1x3 and a corner in there. And the 1x3 obviously can't go on the left side, so it has to go on the right side. We're looking at this side. That can't be a corner piece. That can't be a 1x3 because we already determined that that's a corner piece. So those force all the way up because those all, we knew the red and the green there had to be corner pieces. That has to be a 1x3. That's the only thing that can fit there, and that's a corner. Now we got the entire bottom. Looking over in the middle here, we see that can't be a 1x3. There has to be a 1x3 off the green, but it can't go up and down. So it has to come straight in the middle. And then that has to be a corner piece. And now it's basically forcing the pattern in here. And we can see how it goes, but can't really articulate why the corner has to go a certain space. So we're going to switch over to a different tact here. Much easier to see. If we start down at the bottom, that has to be a 1x3. That has to be a 1x3. And then what's remaining is the corner piece. Yep, there's that puzzle. Let's move on to the next one. All right, we've got the 1x3 shape bank and the corner piece. And so we can just go ahead and fill some of these in. That's kind of forced. That has to be a 1x3. That has to be a corner. Also there, that has to be a 1x3. That has to be a corner. That's forced. That has to be a 1x3 because it can't go horizontally. So that has to be a 1x3. That also has to be a 1x3. It can't go vertically, so it has to go horizontally. That has to be a 1 by 3. That has to be a 1 by 3. There's the difference. Has to be a corner. So there's the corner. Easy peasy. All right, similar situation, this time with the Geminis. Start with the 1 by 3. Start with the corner. That has to be the same, so it's also a corner. That has to be a 1 by 3. Can't go horizontally, so we have to go vertically. That has to be a 1 by 3. Nothing else fits in there, which means if we go to the left, that has to be a 1 by 3. And the only way it can grow is down. That means that's a corner, which means that's a corner. The bottom has to be a 1 by 3. So we know that those are the same. And that's a 1 by 3. That has to grow out. So that has to be a 1 by 3. Those are the same. Has to go horizontal, and that's a 1 by 3. There's that puzzle. All right, we're going to look around here. See if they hid any puzzles anywhere. All right, much bigger space. 1 by 3s and 1 by 4s. We got Gemini, we've got Delta. So anywhere we see a corner, we have to have at least a 1 by 3 in there. All right, those are different. So that's a 1 by 4. That's at least a 1 by 3. Could be a 1 by 4. We don't know, but we'll just. Okay, now this is, we got a line that both sides are different from the other. So whatever goes there, that still has to be a 1 by 3, but that one says that has to be a 1 by 4. So we know those can't be the same region. So that grows out that direction. This is a 1 by 3, that grows to there. That's also 1 by 3, so those grow to there. And I don't think I caught it right here, but those are done. All right, that's different. It has to be at least a 1 by 3. I don't know if it goes up or horizontal. So now we're going to look at this weird little box in the middle. Considering what happens if, there has to be a 1 by 3 that ends, a 1 by 3 or a 1 by 4 that ends in there. And considering what happens if it goes up or down, because next to it are two different shapes. So if we just presume if it went down, those can't be the same shape, because one has to be the same, one has to be different. And no matter what we put in there, I can't put a 1 by 3 and a 1 by 4 in that column. So it can't go vertical. That just can't happen. So it doesn't matter what I go, if I have 1 by 3 or 1 by 4, those have to be different, but there's no room for them to be different. I can't put a 1 by 4 and a 1 by 3 both in that section. So that can't happen. So if we go horizontally, we've got the similar situation, but this time we have more space. Again, we don't know if it goes further. We know those are different. So if we compare these two, one of them has to be a 1 by 3 and one of them has to be a 1 by 4. That one's going to have to be a 1 by 3, which means this one's going to be the 1 by 4. The one above it also has to be a 1 by 4. So we get that. Draw our lines. This has to be a 1 by 4. That goes down. There does have to be a shape right there. And it has to go up. And it has to be a 1 by 3. This does need to be a 1 by 3. If I go horizontally, it's going to create an orphan zone. So we do go vertically. And now I just need two 1 by 3s to fill that in. All right, now we look at this last bit here, and this is where we realize, oh, wait a second, these are already 1 by 3s. These are done. So this is New region. So it has to at least be a 1x3, but it can't be more than a 1x3 because it wouldn't be able to put another space in there. And we'll just fill these in right now. And on the top, we got to fit this in. So coming from the right, that has to be at least a 1x3, but there's no room to put a second 1x3. So we're going to have to extend both of these by 1, make them a 1x4s, and complete. Moving on. Got a 1x2 and a 1x3 to choose from. We do have Geminis and we do have Deltas. So we can start with that corner right here. That it has to be a 1x2. The only thing that can fit in there. This could be a 1x3. We don't know. But we do have an interesting situation here in that the one to the left is the same and the one below is different. But then if I go to the left of that, it has to be the same again. So the question is, can I prove that those are two different regions right there if I drew that line? And to show that it is, I'm just going to assume, what if they were the same region? What if that pink line belonged to each other? Well, then that says that the green line and the pink line have to be the same. The yellow line has to be the same, but the green line and the yellow line have to be different. We have a commutative property violation here. So all that to say, the pink cannot be there. There has to be a line there. So we know we have two 1x2s there. That has to be a 1x3 because it is different. This is going to have to be a 1x3, and then next to it also is going to be a 1x3. That could be more. That has to be at least a 1x2, but if it's not a 1x3, it's going to create a problem. So it's going to be a 1x3. That is not the same, so that's a 1x3. That is the same, so it's a 1x3 going up. And we just have to fill that in. Don't have any orphans. That has to be the same. It's a 1x2, and there's a 1x3. Complete. All right, where are we at here? We got a Delta, and we have a Gemini. And we have no shape restrictions. So we start in that corner here. We know that's a 1x1. We know that this has to be different, so it can't be a 1x1, so it has to grow at least a little bit, but the same thing's true there. So those both come out, and that's the beginning of a shape, but the shape above it is the same. It's got to be the same shape. All right, so that's going to have to grow. I'm just going back and revisiting this logic. They have to be in this kind of a, like that. There's nothing that, there's no way that cannot be that weird shape, that the L, the corner shape here. And this is going to have to grow out of there. And these shapes are going to have to be the same. And so what we're looking at is we're looking at two ends of the same shape that's been rotated or mirrored. And so one end has that little corner on the end, and the other one has a kind of long tail. And we know that that piece is different. And so that shape's going to have to grow. The orange shape is going to have to grow. It's going to have to grow at least to right here. It could go up and around like that, but either way, it has to go that direction. Not sure which shape it's going to be, but it is going to be. So the blue shape also has to grow at minimum to here, because it has to get to a point where it can get to where it can get that corner shape end on it. And the orange shape has to be able to have this long, the 1x3 tail with the long section going to it. So if it has this 1x3 like this, that's a little bit too long, but something like that. It has to grow. It has to grow up. It has to grow long like that. Yeah, it only needs to be 3 long at the end. And then that has to have the tail on it, the end. And then this has to be, we have to connect the green and the orange like that to make the same shapes. Now those shapes are the same. And I can't, if I expand those shapes in any direction at all, it will unbreak the mirroring. So I can't extend them all. So everything else just has to be a one-off shape, because I can't extend the shapes at all without violating the symmetry. So that becomes the forced solution there. So again, we're kind of having like, it's almost like trying to solve the shape from both sides simultaneously, looking at the end and the beginning and forcing them to fit together. So again, I mean, these types of problems, it is a little bit, it's not trial and error per se, but it is exploring the space with the shapes to understand where a shape can and can't go. And once you have certain things are forced, and then you recognize, okay, I have to match things on the other side to force the symmetry to go back around. And yeah, you can see all the symmetry there. All right, we've got a big chunk of it done, but there's a hidden one. All right, so we got a 1x3, I'm sorry, 2x2 and an L pentomino. And every one of these boxes is going to have some kind of pattern like this. It's either going to be, some rotation or things, but they're going to all fit together to fit into the 3x3 box. And just using the Geminis and the deltas to determine which ones go where. So I'm going to start right here and look at what happens if that length of line is part of an L, whether it's at the top or the bottom. But just if that length is an L, that creates a weird situation on the other side, because at the top it's saying it has to be different, but in the middle it has to be the same. And that's just not possible. There's just no way that it can be. The L either goes the entire length of the way, or it's only at the top or the bottom. So we know that the middle there is a 2x2. We don't know if it goes up or if it goes down, but we just know that the 2x2 is there, and we know that that side is also a 2x2, also could go up, also could go down. And we know that it's opposite. One of them will go up and one of them will go down. And then the outside edges are the all right, so we can go into this box here. That has to be the same, so that's the L, and that has to be different. That's the 2x2. All right, we know that has to be 2x2 because the L in the box there, so that's a 2x2, and that's forced. We don't know if that L messed up. We don't know if the L in the box there is the top or the bottom, but it could go along the bottom. It could go along the top. If it goes along the top, this saying that that's different. So that would have to be a 2x2. If it goes along the top, that has to be the same. So. And if it goes along the top, then that has to be the 2x2 up there. If the 2x2 is on the bottom, then this would have to be the L. Again, one of these has to go up and one of these has to go down. So if that was the one that goes down, then that has to be the 2x2. If that's the one that's there, then that has to be a 2x2. But either way, that would say that has to be the same, which means that has to be different, which means that would be the L, and then that breaks there. Now I'm going to go back and look at this a little bit different so that it doesn't feel as kind of just examining. The question is right here, how all of those shapes interact. So because one of these has to be a 2x2 on the bottom, one has to be a 2x2. So if this is a 2x2 right here in this corner, we are forcing that to be a 2x2 in this box, and we're forcing both L's to go along the bottom of their respective boxes, which we know can't happen. So we know that those cannot be 2x2s that are connected across there. Those have to be the L's connect there, which forces the 2x2 to go down. That has to be different. I'm off. I've messed this up here. I'll figure it out here in just a second. Oh no, I messed it up. All right, back it up. Back it up. All right. That's correct. That's different. Yeah, I've made it the same. All right, like that. There we go. Very easy to make silly mistakes like that. All right, those are the same. That's different. So that line has to go down. That has to be different. So the 2x2 is there. There we go. That's done. 32 out of 33. Hidden one. All right, 1x2 and a F pentomino. I believe that's what it's called. That's what I'm going to call it. So the corner there has to grow both directions. So that is going to have to be an F pentomino. And that's the only way the F pentomino fits there. We know that this is the same shape, so this is also going to be an F pentomino. Down here at the bottom, this has to extend, that has to extend. Also a forced F pentomino. That's different, so that's a 1x2. Top corner, gonna also have to be an F pentomino. Okay, that's how the F pentomino shape has to work. But if we do it like that, got a couple different ways to make the shape here. If we do that, that shape does work, but it creates two voids. So to make this, this F pentomino has two ways you can make it. It can either come out like this, or it can come out like that. That's the two ways. And we have to go, if we go the other way, we'll create a void. That creates a void there. So we have to come down. That is forced. Now this F pentomino has to grow out, and it has to grow up, out, and down. All right. Okay, I've got another F pentomino at the bottom, and this may or may not be an F pentomino. We'll have to figure it out. So we basically here have a confined space that we have to fit one of two shapes in. And what I'm going to do is count the number of cells we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14 cells that we have to fill a 1x2 and a F pentomino. And that the 1x2 obviously is 2. The F pentomino, the fact that a pentomino means it has 5. So some combination of 2 plus some combination of 5 equals 14. And we know we have at least one 5, which means we can't have only one 5. We have to have at least two 5s. Otherwise, we have an odd number, right? 14 minus 5 is 9. And there's no way I can fill 9 spaces with 1x2s, which take up 2 spaces. So we have to have at least 2. And we can't have 3 because 3 is 15. So there's exactly 2 F pentominos and then exactly 2 1x2s. So looking at the different shapes, we have 2 ways we can make this pentomino. If we go this direction, that creates a corner space, no way to fill it. So we do need that. We have to take that cell there no matter what. The 1x2 has to fill there, and the F pentomino has to fit in that shape. So there's one of the F pentominos. There's one of the 1x2s. That has to grow. Now the question is, which one of these is the F pentomino? Which one's the 1x2? And the answer is the blue is the F pentomino. All right, we've made it. We have a golden now, when I did this over on the rose window, I got 33 out of 33, and I had a +2. I got +2s. I kind of want to get there has to be some way to get a +2. So something either opened up or I missed something. They hide these puzzles so well. Aha. All right, folks, we're going to have a little bit longer of an episode here because we are not finishing out this episode without finishing out the Gemini and Delta window. All right, so we have no shape restrictions. We do have deltas. We do have Geminis. It's going to be very similar to the other one where we're trying to do, just use the patterns to figure out. All right, so we have to have at least a 1x2, or at least because it has to grow. Those are both at least 1x2s. And if I grow that other one down, if I grow the yellow down, there's nowhere for the blue to grow. So the orange is going to have to grow because it can't be the same as the 1x2. Now, if I do this, this actually looks like it works. We have a corner next to a corner, but now what happens? Because this is telling me that this cyan color on the other side has to be the same corner shape, and I can't put a corner in there. So even though it looks like this could work, it doesn't work. So this is not the right shape. So the question is, can we grow the yellow in any different way? No, we can't. The orange does have to grow. Can I make the shapes bigger? Instead of making them the smallest possible, maybe if I make them bigger, it'll look differently. Because no matter how I grow the blue, no matter how I grow the yellow, they can't go around the edge because they'll conflict with each other. So whatever's on the bottom has to be the same as what's on the top. And the orange or the yellow, one of those two has to grow. And if we grow this yellow, we have the same problem here. See, the blue's not going to happen. So it has to be the orange. The orange has to grow. Now, if the orange grows extra, And we're saying, okay, the pink grows extra. See, if the pink grows extra, then it comes up and those match. It's two L tetrominoes. And that's it. We just fill in that less space. We're done. All right. No space restrictions. That has to grow. They're the same. So here we are going to have to just find two shapes that can fit into the same space. So we're looking at two ends of the same shape. One end has a corner on it, one end has a long line. So you have to do something like, we're going to have something like this. We're going to have something like a corner at the end. And then that one has to be able to grow and have a long line. And so we grow those together, and then whatever's left over, we fill it in. And that's it. That's it. We got the 33 out of 33 with the +2, folks. Let me know what you think. If you enjoyed this, sorry about having to do the voiceover. Anyways, hit that like and subscribe. We'll see you guys next time. We got a new series. I don't know what's in this one. Have to come back for it.